Hello everyone. In this video, I am going to discuss with you the chemical reactions of one of the very important concept of class 12 chemistry, chapter amines, and the topic is benzene diazonium salt. In this video, I am going to tell you very easy tricks to learn the chemical reactions of benzene diazonium salt. So let's start with the chemical reactions of benzene diazonium salt. See, there are so many reactions of benzene diazonium salt and I will tell you very easy trick to learn the reactions of this salt. See, this is the formula of structure of benzene diazonium salt. Benzene with N2 positive Cl negative, or it can be represented as benzene and positive charge triple bond and Cl negative, because this N is having four bonds, so it is showing positive charge, Cl is showing you a negative charge. So this is the structure of benzene diazonium salt. So let's start with the first reaction of benzene diazonium salt. Here I'm showing you X negative because it's not always Cl negative. It can be Br negative, it can be HSO4 negative or BF4 negative. So let's suppose it is Cl negative. So the first reaction is with Cu2Cl2 in presence of HCl. Here Cu2Cl2, it acts as a catalyst where your HCl is your reactant. So how to learn the reaction? What is the easy trick for this reaction? See, you will remove this N2X from the benzene, and in place of this N2X you will apply this Cl on the benzene. Very easy trick is इस N2X को यहाँ से रिमूव करना है और इसकी जगह पर जो भी मॉलिक्यूल आप रिएक्शन करा रहे हैं उसका लेटर पार्ट, उसका बाद वाला पार्ट Cl उसकी जगह पर सब्स्टिट्यूट करना है. So this is very easy trick. So what will be the product? What will be the product? See, in place of this N2X, you can see the molecule is chlorobenzene. Cl is in place of N2X, so your product is chlorobenzene. This reaction is called Sandmeyer reaction. So what is the easy trick? You have to remove this part N2X and you are treating with HCl. You are treating with HCl, so you will substitute this N2X by the later part of your attacking reagent. So this is Sandmeyer reaction. If you suppose react with Cu in presence of HCl, again your later part of the molecule is Cl. So you will substitute this N2X and you will apply Cl. This is Gatterman reaction. So both reactions are giving same product. If suppose there is a question which reaction is better, your Sandmeyer reaction is better than Gatterman reaction. Both are giving same product, but in Sandmeyer reaction we get more yield of the product. So this is the first reaction. Let's see the second reaction. Now again you have your benzene diazonium salt. This time we are treating this molecule with Cu2Br2 in presence of HBr. Cu2Br2 HBr. Again, what is the easy trick? You will remove this N2X and in place of this N2X you will apply what? Br. This is again Sandmeyer reaction. If it is Gatterman reaction, your catalyst is Cu in presence of HBr. Again, the later part of the molecule is Br. So you will remove this N2X and in place of this N2X, what will you apply? Br. So this is your product. Yes, in Sandmeyer reaction, you can write CuCl, CuBr also. That Cu is also having +1 oxidation state. So both are same. So this is your second reaction. See the product. Your N2X is substituted by the Br. So this is bromobenzene. Let's see the next reaction. Now the reaction is with Ki and it's very easy. Remove this N2X and what will you apply in place of N2X? Obviously this I. So I will be here. What will be the product? Obviously iodobenzene. Correct. Next reaction is with CuCN in presence of KCN. Your CuCN is a catalyst just like your Sandmeyer and Gatterman reaction, and the main reactant is KCN. This is KCN. So again the later part of the molecule is CN. So in place of N2X, what will you apply? Obviously this CN. Now see the product. This is benzene with CN. Form the bond with C, not with N, because this is benzene nitrile, not benzene isonitrile. So this is the next reaction. Let's see the next reaction, and this reaction is with water. Here your benzene diazonium salt, it is treated with water. Whenever you use water in organic chemistry, always write HOH. Always write HOH. H is having a positive charge, OH is having a negative charge. So again, in water, what is the later part? OH. So it's very easy. Remove this N2X and apply your later part of the molecule, and that is OH. So your product is phenol. So in all these reactions, I think now you get the trick. You are replacing this N2X by the later part of the reacting molecule like Cl, like Br, like I, like Cn, and in water, this is OH. But in the next reaction, the trick is quite different. See, the next reaction is with alcohol molecule. This is with alcohol molecule, and another molecule is H3PO2 plus water. So here the molecule is alcohol, but I'm not replacing this N2X by the OH part. Why? Because already we have used this OH of water, so that means I will not use OH of the alcohol molecule. So see, whenever alcohol is there, we remember nothing. कोई भी पर्सन जब अल्कोहल लेता है तो उसे कुछ नहीं याद रहता, तो आपको क्या करना है, N2X हटा के मॉलिक्यूल बेंजीन के ऊपर कुछ नहीं लगाना, मीन्स H आएगा, दैट मीन्स कुछ नहीं लगाना. Again we have H3PO2 plus water. See, water we have already used alone. So in case of H3PO2 plus water, there is nothing to replace this N2X. So again the product is benzene. So in only these two reactions, H3PO2 plus water and with alcohol, your benzene diazonium chloride will give you benzene. Okay, so these two reactions are different from other reactions. Now see the next reaction. This is actually the conversion of one type of your diazonium salt into another type of diazonium salt. ये ऐसी रिएक्शन है जहां पर in the first step you will not replace this N2. Yeah, the N2 will remain with the benzene molecule. You will replace only X by the BF4 ion. So only for this reaction you will not substitute whole N2X. For only for this reaction you will replace only X negative. Suppose this is Cl negative or Br negative. So you will replace this molecule by the later part, but not the full N2X. Only BF4 will be in place of X negative. So your product is benzene diazonium fluoroborate. Benzene diazonium fluoroborate. So for the next two reactions, we'll focus only on this molecule. Only on this molecule. I will show you two reactions of this benzene diazonium fluoroborate. See, this is our benzene diazonium fluoroborate. When we heat this molecule, there is no other reactant. There is no other reactant. So what we will do? See the later part of your molecule. This is only F. See the later part of the molecule. This is only F. So you will remove this whole part, and your product is having only F on the benzene. So this is fluorobenzene. Correct. And for the next reaction, see this one. This is your next reaction. Here we treat our fluoroborate with Cu and NaNO2. So Cu is again your catalyst, and your reactant is having NO2 as a later part. So again you will replace this whole N2BF4 by NO2, and your product is what? Nitrobenzene. Your product is nitrobenzene. Correct. So this is the next last reaction of this benzene diazonium salt, and we can convert this nitrobenzene into aniline also. See this reaction. We can convert this nitrobenzene into aniline also. I'll tell you one thing. This is the only reaction to convert NO2 into any group in our syllabus of class 12 chemistry. If you suppose have benzene with NO2 or aliphatic molecule with NO2, your NO2 can only be converted into NH2. There is no other option. So these are the reducing agent, because we are removing O, we are applying H. So Sn plus HCl, Fe plus HCl, H2PD or other reducing agents can be used to convert NO2 into NH2. So this is the conversion of nitrobenzene into aniline, and we can also convert our aniline into again back into our benzene diazonium salt, and the reaction is called diazotization reaction. I think you must know this reaction, very important for the preparation of benzene diazonium salt. So these are the reactions of benzene diazonium salt. This is all about this its reactions. Thank you. All the best.